So any linear pattern has got a general equation. Okay? So that general equation, you need it in order for you to determine all the terms in the pattern or in the sequence. You also need it to determine the position of a term. Sometimes you need to determine the value of the term. So I'm going to start by introducing the general term. Okay, the general term. Let's start by defining rather what a linear pattern is. A linear pattern is a sequence of numbers that has a common difference between any two consecutive terms. Okay, so a linear pattern has got what's called a common difference. And that common difference is constant. It doesn't change. Okay? So let me move on to the general term. Okay, we move on to the next page. General term of a linear pattern. General term of a linear pattern. I hope by now, since you did grade 8 and 9, you should know that the general term is denoted by, rather, the term of any signal is denoted by Tn. Okay, I expect you to know that. So the general term is, the general term is Tn equal to, let's use An plus C. Right, I'm going to define all those letters, what they mean, okay? Where, where Tn is the nth term, right? A, this one is called the common difference, okay? Whereby A is what is a general formula. It will be A is equal to, say, T2 minus T1. It's also equal to T3 minus T2. So generally we can write it as Tn minus 1. Okay? N is the position of the term. Of the term, right? And C is a constant. C is a constant term. So in grade 8 and 9, when you're doing number patterns that were linear, you probably were not using a specific formula to determine all the terms in that sequence. But now you can use a formula that can help you to determine all the terms, to determine the position, to determine the difference between the terms and so on. But generally, when you're using this formula, you have to be given the sequence. So you have to calculate the common difference first. Right? So let me move on to an example. So it's not very difficult, it's very easy. It's one of the easiest topics in grade 10. So you shouldn't have any major problems there. Right? Then let's do an example. So I'll just do some examples and then we stop for today. Maybe I'll give you homework, I'll talk about it tomorrow, and then we are done. Right, so let's do some examples. Right, I'll start with 3a. So 3a we are given 2. So the question says find the general formula. Now the general term is also called the general formula for the following sequences, and then find T10, T50, and T100. So, well, we have got 2, then 5, then 8, then 11, and then 14. Okay, so here we need to determine the general term first. So to find the general term, obviously you can say T2 minus T1, that's a 3. T3 minus T2, that's a 3. T4 minus T3, that's a 3. T5 minus T4, that's a 3. So in this case, our A is going to be equal to 3. So A is going to be equal to 3. So write the general equation, Tn equal to An plus C. Alright, then you have to choose a term in the sequence and determine its corresponding position. Then substitute the value of A, which is a 3, because we have to calculate C. So you have to calculate C first before you you get the general term. So in this case, I'm going to choose the third term. Right? It's your choice. So I'm going to choose the third term. So it means where there is Tn here, I'm going to put 8. Where there is A, I'm going to put 3. Where there is N, I'll put 3. Because 8 is the third term in that sequence. Then plus C. So I need to calculate what C is. So C is going to be minus 1. Then I have to substitute back now into this equation. I'll substitute C, which is minus 1, and I'll substitute A, which is 3. Therefore, my general term is going to be Tn equal to 3n minus 1. So this general term, I can use it to determine all the terms in that sequence. Like for example, if I put n equal to 2, okay? If I put n equal to 1 rather, 3 times 1 gives me a 3, 3 minus 1 gives me a 2. If I put n equal to 2, 3 times 2, that's 6, 6 minus 1 gives me a 5. N equal to 3, that will give me 9, 9 minus 1, that will give me 8. If I put n equal to 4, I'll get 12, 12 minus 1, I'll get 11. So generally, your general formula or general term must be able to give you all the terms in the given sequence. If it doesn't, it means the general term will be incorrect. All right, so I've calculated the general term. Then the next thing now, I need to calculate what is T10, T50, and T100. Right, now to calculate those terms, I just have to use my general term. So my general term is Tn equal to 3n minus 1. So T10 is going to be equal to 3. Remember, just to remind you that in this general term here, this n here is the same value that you put there. Right? They are related. So T10 means that my n is 10. So I'll put 10 then minus 1. So the final answer will be 30 minus 1, which is equal to 29. So T10 is going to be equal to 29. Then I need to calculate T50. T50 is going to be 3 times 50 minus 1. This is equal to 150 minus 1, which is 149. Then T100 is going to be equal to 3 times 100 minus 1, and that will give me 300 minus 1 equal to 299. So I'm done. Right, so it's very simple. Now, so I've calculated the general term, I've determined the general term, I've determined a specific term, an nth term. Now, sometimes you may be asked to determine the position of a term, right? So let's determine, say, the position of it, the position of, say, you see, in this case, let me just approximate that. Well, if I got this general term, uh, let me just, I'm just going to create a new question whereby we have to calculate n now. Because we have calculated C, we have determined A, we can determine n as well. We have determined Tn, so we now need to find what is that n, that is the position. All right, so let me just give me a second. Okay, like example, we can ask to determine the position of a term with a value of 95. Okay, so if uh, if the value is 95, okay, so let's say Tn is equal to 95. But our general term is Tn equal to 3n minus 1. So we want to determine what is the position of 95 in that sequence. So all we have to do is substitute 95 where there is Tn. So we end up with 95 equals 3n minus 1. And then we solve this. So it will give us 96 equal to 3n. Then we divide both sides by 3. Okay, so 3 into that, we end up getting 32. So what this means is that the position of 95 will be the 32nd term. Alright? So it's very easy and it's very, very straightforward. Okay. Alright, I need someone to confirm if you are following what I'm doing.
Yes, sir.
Right, so what I'm going to do now is, was this topic, it's a very short topic. What I have introduced here, that's the key. Right, so I'm going to give you homework, then we'll talk about it tomorrow, then that's it. So today's lesson will end here. Okay, I don't have much to say because it's a very short topic.